Hey everyone, and welcome back to the channel. Have you ever wondered what's right beneath your feet? Like way, way down? Today we're going on an epic journey to the center of the Earth, peeling back its layers like a giant super hot onion. Forget what you've seen in the movies, the real story is even crazier. So let's start with the ground we're standing on. This is the crust. It's the thinnest layer, kind of like the skin on an apple. It's where we live, build cities, and grow food. But this skin is broken into huge pieces called tectonic plates. These plates are constantly, slowly, drifting around. When they bump into each other, we get earthquakes. When they pull apart, magma from below can rise up, creating volcanoes. It's a pretty dynamic place to live, even if we don't feel it most of the time. The crust under the oceans is thinner and denser, while the continental crust we live on is thicker. Now, let's dig deeper. Right below the crust is the mantle. This is the biggest layer by far, making up about 84% of Earth's volume. It's a behemoth. The mantle is mostly solid rock, but here's the wild part. It behaves like a super thick, slow-moving liquid over millions of years. Imagine honey, but a million times thicker. This slow, churning motion is called convection. Hotter, lighter rock from deeper in the mantle rises, cools down near the crust, and then sinks again. These massive convection currents are the engine that drives the movement of our tectonic plates up on the surface. So the ground beneath you is literally floating on this slowly churning sea of rock. The mantle isn't just one uniform blob either. It has an upper part and a lower part. The very top of the upper mantle is rigid, and together with the crust it forms what scientists call the lithosphere, that solid, rocky shell of our planet. Just below that is a zone called the asthenosphere, which is the slightly softer, more plastic part of the mantle that allows the plates of the lithosphere to slide around. It's the geological banana peel that everything slips on. Okay, are you ready to go even deeper? We're about 2,900 kilometers or 1,800 miles down now. We've just reached the outer core, and this is where things get really interesting. The outer core is pure liquid metal, mostly iron and nickel, and it's incredibly hot. We're talking temperatures between 4,000 and 5,000 degrees Celsius. That's hotter than the surface of the sun. So how do we know it's liquid? We can't drill down there, obviously. Scientists figure this out by studying seismic waves from earthquakes. Certain types of waves, called S waves, can't travel through liquid. When a big earthquake happens on one side of the planet, seismic stations on the other side don't detect any S waves passing through the core. It creates a shadow zone, which is our big clue that the outer core is molten. This swirling liquid metal ocean is also a hero. The movement of this conductive iron generates a powerful magnetic field that extends way out into space, surrounding our planet. This magnetic field acts like a protective shield, deflecting harmful solar winds and cosmic radiation from the sun. Without it, the sun's radiation would strip away our atmosphere, and life as we know it wouldn't be possible. So, next time you use a compass, give a little nod of thanks to the churning liquid iron thousands of miles beneath you. All right, we've made it to the final destination, the very heart of our planet, the inner core. It's about the size of the moon and is even hotter than the outer core, reaching up to 6,000 degrees Celsius. But here's the mind-bending twist. Even though it's hotter, the inner core is a solid ball of iron and nickel. Wait, how can it be solid if it's hotter than the liquid outer core? The answer is pressure. The pressure at the center of the Earth is absolutely immense, over 3.6 million times the pressure at the surface. This incredible, crushing force is so strong that it squeezes the iron atoms together, forcing them into a solid state, even at those insane temperatures. It's a solid because it has no choice. And what's even crazier, recent research suggests the inner core might be spinning slightly faster than the rest of the planet. Scientists are still debating this, but it just goes to show how many mysteries are still locked away deep inside our world. We're constantly learning new things about the ground we live on. So let's recap our journey. We started on the crust, the thin, rocky shell broken into moving plates. Then we traveled through the massive, slowly churning mantle, the engine that drives plate tectonics. We dove into the liquid metal outer core, the source of our planet's protective magnetic field. And finally, we reached the solid, super-pressurized inner core, a white-hot ball of iron at the very center of it all. Exploring the deep Earth is a story of extreme temperatures, incredible pressures, and dynamic forces that have shaped our planet for billions of years. Everything from the mountains and oceans on the surface to the very air we breathe is connected to these hidden layers. We can't see them, but their influence is everywhere. It's a reminder that there's a whole other world right under our feet, constantly churning, shaping, and protecting our own. Thanks so much for joining me on this deep dive. I hope this made you look at the ground in a whole new way. If you found this journey fascinating, please hit that like button and don't forget to subscribe and turn on notifications so you don't miss our next adventure. See you in the next video.